Right, today we'll discuss 6 questions from electrochemistry which appeared in a CSIR from December 2011 to December 2013. Okay, for an enzyme catalyzed reaction, did I say electrochemistry? Yeah, chemical kinetics. Okay, chemical kinetics questions. For an enzyme catalyzed reaction, a Lineweaver-Burke plot gave the following data. And you have been given with a lot of data. What you have to find is catalytic efficiency. Okay, so catalytic efficiency is not, this all I have taught in my first video. I'll attach the link, you can go and check out there. So directly the formula is 1 by slope into E naught for the catalytic efficiency. Okay, don't get carried away by the lot of data given, thinking if intercept is given, why am I not using it in the formula, am I going wrong or something like that. Don't think in that way. The examiner will give you a lot of data just to confuse you. You have to be confident with whatever you have learned. Okay, so directly the formula, substitute the slope value 40, E naught value is initial concentration 2.5 into 10 power minus 9, and if you solve it you will get your right option as C option. Okay, now next question, the overall rate of the following complex reaction. You have been given with a complex reaction by steady state approximation is. So what is the overall rate for these reactions according to SSA? Okay, now, so rate of the reaction is given for the step which is your slow step, I mean rate determining step, where the product is formed. Okay, so d of product by dt. And if you look at the reactions, where is the product formed? Here. So K3 into P in K3 into A2 into C is the product formed reaction. This is the rate of the reaction. What you have to find, where A2 and C are formed. Okay, so according to SSA, where you will get your A2 and A, this K1 into A square, this will give you your A2 concentration. And where is C formed? Here, K2 into A into P. So as soon as you get these two concentrations, directly substitute in the rate equation. So rate equation is K3 into A2 value is K1 into A square, C value is K2 into A into B. So if you write the whole thing at a place, you will get that K1 into K2 into K3 is A cube into B. Okay, this is your final answer. Such a simple question, no complications at all. There's no step where rate of formation and rate of dissociation is given. Okay, only rate of formations are given. Had it been some dissociation step, you would have got at least confused somewhere, but there is no confusion. Very simple questions. Please concentrate on chemical kinetics. Very scoring for the entrances. Okay, in the Michaelis-Menten mechanism for the enzyme kinetics, the expression obtained is, and the value of K3 and Kr, you have to find K3 and K from this particular Michaelis-Menten, one of the what can I say, one of the derived forms from the standard Michaelis-Menten equation. Okay, what is the standard form of Michaelis-Menten? I have told you is nu is equals to nu max into S by S plus Km. Okay, we know that Vmax is K2 into E naught, but here it is given to find K3, and that's fine. Okay, so K2 into E naught will substitute as K3 into E naught into S by S plus Km. Right, now we'll try to write this particular form in this particular given form. Okay, we have to write the standard form in this particular form and then compare the values to find K3 and K. This is the goal. Now to write in this form, you will try to get V by E naught into S. Okay, so V by E naught into S will give you K3 by S plus Km. Right, now V by E naught into S, you have got it, but you did not get this right hand side, but that is also important. Now you have to solve it in such a way that you even get the right hand side, and this you can see that this is a constant. Okay, so you have to solve in such a way that this value is equals to some constant minus some value V by E naught. Now how do you do that? Try to take this over here so that you will be left with K3 as some constant as it is there over here, and then solve it in such a way that you even get this particular thing. Okay, just try to solve it. Take this to the left hand side is equals to K3. Now multiply this whole term with this and this, V into S by E naught into S, right, and then V into Km by E naught into S is equals to K3. Now S get cancelled, V by E naught plus V into Km E naught into S is equals to K3. In the next page what I will do is, this whole thing is equals to K3 minus V by E naught I will write. Why? Because given form is V by E naught into S, that is V by E naught into S I am getting over here. So this I equate it to K3 minus V into E naught. Okay, now after writing this form, now this form and compare the given form. Where is the difference you find? Km. This is the extra value when you compare with the standard given form. So what you'll do is you also take the Km to the right hand side. So K3 by Km minus V by E naught into Km. Okay, so K3 by Km, now that these two are equal, you can compare the values. Okay, so how do you compare? K3 by K0, Km is this value, and from these two equations you can see that V by E naught into Km is equals to 10 power 4 E naught into V. If you cancel V and E naught, you'll get 1 by Km is equals to 10 power 4. So if 1 by Km is 10 power 4, then what will be the Km value? 10 power minus 4, right? Because 1 by Km is 10 power 4. So 1 by 10 power 4 is Km, and Km is equals to 10 power minus 4. So this is what you get from this particular derived form. Now you substitute that Km value in this form. K3 into Km is this. K3 by Km is 10 power minus 4. You solve it for K3. Okay. So these are your answers which is being given in one of the options. So 1.4 into 10 power 8 and 10 power minus 4 is the right choice. Okay. Now the Arrhenius parameter for the thermal decomposition of NaCl is given. You have been given with the A, EA, RT. Have to find the enthalpy of the activated complex. This is the point you have to focus on. If you go with the final product formation, the formula which I have written in my next page would be different, but because it is given for the activated complex, what you have to know is that in the activated complex also two molecules participate, as it is a bimolecular reaction. Okay, so for a bimolecular reaction, delta H is equals to EA minus 2RT. Okay, for activated complex I have written this formula. Now delta H, okay, so actually standard formula was EA minus delta N minus 1 RT. Okay, this is the standard formula, and delta N is gaseous products minus gaseous reactants. So if you go with that way, you will not get minus 2 RT, but because you have been asked with the activated complex, and even in the activated complex two molecules, that is NOCl are involved, it becomes a bimolecular reaction, and you don't go with this formula because this is only when the products minus reactants. But here it's not asked about the product, only activated complex. That is the point you have to stress on this question. Okay, so this is the formula. So EA is 105 minus 2 into RT value is given as 2.5, so 100 is your answer. Now this question made me to record the video again because I was going wrong in the option C. Okay, so the rate equation for the reaction is given by this form, a possible mechanism consistent with this rate law. Okay, for this particular equation, if this is the rate equation, among the following four, which one of them will also be consistent with this particular rate law? If you look at the options, what I have found is that option D to be the right one, but in the answer key it has been given as the option C. Okay, so that's what confused me, and I was doing something to solve it for C, but no, C is not the right answer, and D is going to be the right choice. Okay, so if you look at the option A is rate is equals to K into AB2 square. Okay, for this, as it is a slow step, directly you can write Ka AB2 power 2, but this is not consistent with the rate law, so this is not the option. And second option also doesn't matches because rate is AB whole square, and then AB2 is nowhere formed from this particular fast step reaction, so even B is not the right choice. And option C was actually slow, I converted it to fast, everything I changed. Okay, it was also irreversible, and the given was fast. This was slow, this was fast, it was given AB3 AB2. So if you write the rate equation, it will be K AB2. Okay, and then K into, where is AB2 formed? AB2 is nowhere formed from the given equation, it is AB3, so even C is not the right choice. So actually the correct option is D, but the given is C. First let me solve for D. It is K into AB2 whole square. Yeah, K into AB2. Where is so even this is the wrong option then. K AB2 is, yeah, it's nowhere formed. See, it is AB3. Yeah, see, either it could be AB2, then it would be AB, B2 and a whole square 2, but that is not given in the option. So this particular question, 2013 December, I feel all the options are wrong. Why I have taken up this question is just to tell you that even in the exams, sometimes the questions comes wrong and we try to make it right, and then we do not understand how is it not collaborating with the answer given in the exam, and we just leave that option. So never do that. I am not getting right answer for this question. If you are getting, comment down. If not, I feel the question itself is wrong. I mean the options are wrong. For such kind of question, simply mark one of the options whatever you feel right in the exam, because that will fetch you 4 marks. But if you don't attempt thinking that you are going wrong, and if you just leave that question, you will not get any marks. Okay, so when you are getting marks for granted, for free, if you are getting marks, never leave such kind of question. Simply mark one of the option and you'll get 4 marks for free. Okay, so I think it is wrong. Okay, AB2, yeah, this is wrong, and this is the option given as the right one, and here also you will not get AB2. So the question itself is wrong. Okay, so this is what I wanted to tell you. Never go with the options given, and never think that if the data is more, then the question is going to be complicated. More is the data, simpler will be the solution. So with this 6 questions from chemical kinetics, I'll try to solve more and more CSIR questions, because the more you solve the questions, the more easier it will be for you to actually score the marks for your entrances, right? Thank you.